Welcome to the Chest X-Ray Basics module. I'm Lakshmi Krishnan. In this section, we will discuss an introduction to the X-ray, including physics, basic principles, and indications. We will then go over basic anatomy. The objectives of the Chest X-Ray Basics module are to become familiar with X-ray physics, basic principles, indications, and safety profile, to recognize fundamental normal anatomy, to determine if a study is technically adequate, and finally to develop a strategy for reviewing chest films. In this module, we will go over the first two of these objectives. We will also pause the lecture at points for self-study and assessment. Here's an introduction to the X-ray. The history of the X-ray is interesting to know. It was discovered by William Röntgen in 1895. It is the most widely obtained imaging study. The images are produced through the use of ionizing radiation, also known as X-rays. The image on the right is actually the first X-ray that was performed, an image of William Röntgen's wife's hand with her wedding ring. The basics of the X-ray are that it is inexpensive to produce, portable, fast, and easy to obtain almost anywhere. And the requirements are an X-ray machine, also known as the source, a film, cassette, or plate, which is the recording method, chemicals, or a computer, which are the processors. The two images on the right are common X-rays that you will encounter on the wards. The methodology of the X-ray is as follows. A patient is placed in front of the X-ray detector and pulsed with X-ray beams. The image densities are based on absorption by structures of various densities in the body, from air, which is the least dense and black, to bone, which is the most dense naturally occurring and white substance in the body. Metal or artifact are non-natural substances that are denser than bone and appear the brightest white on an X-ray. Here are some important indications for an X-ray. The chest X-ray is the initial modality of choice for lung pathologies. The abdominal film or abdominal X-ray is often used to rule out pneumoperitoneum, which is the presence of free air under the diaphragm, or for suspected obstruction, such as small or large bowel obstruction. X-rays are also extremely useful for bones. For example, if you have a patient with a suspected fracture or a patient with arthritis. The X-ray is not useful when three-dimensional anatomy is needed. For example, when you are imaging looking for abdominal pathology or genitourinary pathology. It is also not good for soft tissue detail, such as musculoskeletal imaging, detailed abdominal imaging, pelvic imaging. It is not high resolution, and it is not useful for precise localization. For example, when you are trying to find a site for a biopsy or a lesion for a biopsy. It is important to understand the safety profile and stewardship issues around various radiologic studies. For the X-ray, we should note that it uses ionizing radiation. This radiation can cause cell mutations that lead to cancer. The burden of an X-ray is more than that of a transatlantic flight and much less than that of a CT scan, a study that we will go over in more detail in those modules. You should avoid X-rays if possible in pregnant women because radiation is teratogenic, but it is safe for most other patients in moderation. We just completed our basic review of X-ray physics, basic principles, indications, and the safety profile. We will now move on to recognizing anatomy. We will start with a normal chest X-ray. As you review the following image, pause the slide to try to answer the following questions. What anatomic structures can you see? And are there important structures that you cannot see well? You can pause the talk at this point and restart when you are ready. Pause again and use this online tutorial to provide an excellent review of normal anatomy on the chest X-ray and to help you answer the previous questions. It should take you about 1 hour. Here are some final thoughts on the X-ray. On a normal chest X-ray, white lines in the lungs are usually vessels. Bronchi, which carry air, are invisible. Note that normal interstitial markings are very light, fine, often nearly invisible linear markings at the lung periphery. Pleura should be invisible, except occasionally when layers fold to form fissures as a fine white line. The right hemidiaphragm is usually higher than the left. Use the lateral chest X-ray to confirm and locate any masses, densities, or lesions seen on the frontal chest X-ray. Remember, 2 views can help reconstruct the 3-dimensional thoracic cavity. Also, don't forget to look at the thoracic spine, which holds a lot of excellent information about densities. The spine sign is a finding that is very important and can be seen on lateral chest X-ray, and we will go over this in much more detail in the chest X-ray cases section. It can be useful when you have a puzzling frontal chest X-ray. Another important note is that it takes approximately 75 cc's or milliliters of fluid to blunt the costophrenic angle on the lateral film, versus approximately 250 to 300 cc's on the frontal film. This becomes important when you are looking for effusions on a chest X-ray. Test yourself with these quizzes. Feel free to go over the module or the quizzes again for self-study. We have now completed our first 2 objectives: to become familiar with X-ray physics, basic principles, indications, and safety profiles, and to recognize fundamental normal anatomy. See you in Chest X-ray Basics Part 2, where we will cover Objective 3, determining if a study is technically adequate. Thank you for your attention and participation. I will see you in the next module.